another video, everyone. I'm Amberly, and I'm so glad you're here. I'm gonna assume that you've been watching these videos for a while. If you're just popping in for today's concept, that's totally okay. But in either case, we've really come a long way, haven't we? If you think back to when you were first getting into programming, to where you are now, how would you say your skills compare? Are your programming skills greater than what they were when you started, or are they about equal? Are you liking this, or are you starting to think maybe this isn't your thing? If you're leaning towards the latter, don't give up yet. The fact that you were able to just make those comparisons with me means that you are totally on track to crush today's lesson, relational operators. Relational operators allow us to compare something on our left to something on the right. If it's time to start, then let's go. So what's a relational operator? It's a symbol that compares the value on its left to the value on its right, and it evaluates the relationships between those two. These type of relationships generally come in two flavors, relational and logical. You're probably familiar with some of the symbols we're going to cover today, especially the math ones. In fact, in our basic math video, we touched on the greater than and less than symbols. So if you need a quick refresher or a tip on remembering which is which, pop over and check that out. Now here we have two numbers. How would you define the relationship between these two? As humans, we might say something like, well, they're both whole numbers, or they're both odd numbers, but computers don't really think like that. They can't apply that external knowledge or context. So because of that, computers can't form or define relationships between things, but they can evaluate a given relationship to see if it's true or not. If I put this here, our program could check and see if this is correct. In English, we would say this as 3 is greater than 5. Let's take a look at a number line. On a number line, we find 0 in the middle because it is neither positive nor negative, but those values are represented on either side of 0. If you move to the right, you get positive integers. If you move to the left, you get negative integers. To the guy who invented 0, thanks for nothing. If we start at 0 and move through the positive integers, do we come across 3 or 5 first? Since the increment goes up by 1 each time, the value that we encounter first will be the lowest. As we can see, here's 3, and then there's 5. So, is 3 greater than 5? No, it's not. So this statement that we have is false. However, if I flip this now reads as 3 is less than 5. Is it true now? Looking at our number line, yes, it would be. And if our program evaluated this statement, it would agree that it is true. 3 is less than 5. Now what about this one? In English, this reads as 3 is equal to 5, which we know is false. But notice how this has two equal signs? Why could that be? Where else in our code are we currently using the equal sign? When initializing our variables, right? In C++, a single equal sign indicates assignment. It is going to try to assign what's on the right to what's on the left. Because in programming, that's our assignment direction. What we have here is a double equal sign, which means that it's an evaluation between what's on the left and what's on the right, not an assignment. I see a lot of students stumble on this, so make a note. Okay, so far for our relational operators, we have greater than, equal to, and less than. As programmers, we use these symbols to evaluate the relationship between the value on the left and the value on the right of the symbol. Now, one of these operators can be modified to change how a condition gets evaluated. For example, we know that this statement, 3 is equal to 5, is not true. But what if I wanted to make it true? How would we say that? What is the phrasing? Well, the part of the statement that's currently false is the equal to. So if I just get the exact opposite of that, not equal to, then it would be true. In C++, we do this by adding an exclamation point. Unfortunately, we can't just put an exclamation point in front of anything that we don't want to be true. It appears here only with equals. But we can add the equal sign to two of our other operators. If we read these in English, they would say less than or equal to, not equal to, and greater than or equal to. These modified operators that we've seen here are all compound operators since they combine two conditions. Now, we have one more flavor to digest, and that is logical operators. These symbols do appear in their natural form, so you'll probably recognize them. And much like the equal sign, when used as part of an evaluation statement, they always appear in pairs. So you may know these as ampersand and bar from your keyboard. Two ampersands together is what we know as the AND operator. When you use the AND operator, both statements on the left and on the right have to be true, independent of each other, for the whole condition to be considered true. The two bars are known as the OR operator. For an OR statement to be considered true, only one condition on either side of the OR operator needs to be independently true. Even if one is true and one is false, the statement as a whole can still be considered true. So, for AND, both conditions on either side need to be true for the whole statement to be considered true. For OR, either of the conditions can be true to make the whole statement true. But what does that mean exactly, to be true? So what if a statement's true? Why do we care? As a developer, you're often going to need to evaluate things. If it's true that this customer already has a record in the database, then I don't need to make a new one for them. If it's false that that customer entered all 10 digits of their phone number, I need to know that so I can go back and collect the correct information that I need. Before we get into the programmatical applications of relational operators, let's see how we use them in our daily lives. Welcome to the Lightboard, everyone. So I've drawn us out a table here, but not just any table. This is specifically what's known as a truth table. And it's a tool that we can use as developers to help us construct and evaluate conditional statements. And that's exactly what we're going to do together right now. So the way that this works is we put a conditional statement up here in one of the header boxes. Today we're going to be evaluating temp to identify warm days, cold days, and perfect days. We can all agree 78 degrees is like right there, right? So in the temperature column here, we have the test value that we're going to be using to determine if this condition is true or false. And then once we determine that, we'll put that right here. So I'm going to give us a bit of a range so that we can kind of like diversify our results here. Okay. All right, excellent. So starting with temp equal to 90, let's look at our first evaluation statement here. And this reads, temp is greater than 50. Would you say that that's true or false when temp has a value of 90? It's going to be true, right? So we can just put a T for true right here. Awesome. What about temp being less than 32? Is that true or false at 90? It's not, right? So we just can put an F right here. And last but not least, temp is equal to 78. We're at 90, obviously not. So we'll put a false here as well. Okay, moving right along. When temp has a value of 55, so temp is dropping, all right? Winter's coming, y'all. Is temp greater than 50 when it's at 55? Yes, it is. Okay. Is temp less than 32 right now? No. So we put a little false. Last but not least, equal to 78, also false. Okay. We're now hanging at a like chilly, frigid 32 degrees. Is our first statement true? Nope. So we're going to put an F right here. Excellent. Now right here for cold day, what about this one? In English, this reads as temp is less than 32, which it is not. It's equal to 32, but it's not less than 32. So what if we wanted to alter this to make it true? Because I would count 32 as a cold day, right? So how could we change this to be true? Well, we could change it to say temp is less than 33, and that would be true. But that's not the threshold that we want for a cold day. All right, that's going to start at 32, and we want to include 32 as part of our acceptable results. So do you remember how we can compound this with the less than operator to something else that we could do to include 32? We could make this less than or equal to 32. So there we go. Situations like this are why it's helpful to draw out our truth table. So we can catch these things in a more like visual way instead of having to F10 and debug every line of code, right? So now, this is now a true statement. Okay? So, very last but not least, temp equal to 78. No, it is not. We had no perfect days. What a bummer. Okay. Now it's time to kick up the heat on our flavor and evaluate some logical statements. So for this one, I thought that we could write our conditions together. So our first condition is hot and sunny. So we have our variables right here, and we've got our values for our evaluations here as well. How would we write out hot and sunny using these variables right here? All right, since we have an and, that tells us something about the condition, right? We know that we're at least going to need some ampersands. Okay? But now we have to put a condition on each side of this. So starting with hot, in this context, we want it to be hot. Or we want hot to be true. It would be another way to say it. So I'm going to write that out like this. And remember, when we do an evaluation, we need that double equal sign. Okay? So hot equals true, and same thing for sunny, right? Because we want it to be sunny. All right, excellent. So for this statement as a whole to be true, hot has to be true, and sunny also has to be true. Now, the next one is similar, but instead of an and, we're going to be evaluating hot or sunny. So let's draw our bars for our or. Now, just like our conditions, we're checking both hot and sunny to see if they're true. We want them to be true in this case. So for hot, same thing. Okay, hot equals true, or sunny could equal true. And either one would make this whole statement true. Okay, excellent. Since it's an or, as long as one's true, we're good. Now, next we have hot but not sunny. This one's a little bit more complex. What do you think that we would need the value of our variables, hot and sunny, to be for it to be hot but not sunny? Well, it sounds like we would want hot to be true, like our previous examples. But since we don't want it to be sunny, that means that we're going to need sunny to be false. So we get our hot equals true. Now, we could set this to hot equals true and sunny does not equal true. You could have also written this as sunny equals false. Either one's going to work, right? Last but not least, hot but not too hot. So now we're roping in a relational operator with our logical operators. Okay, that's totally cool. Let's just take it one step at a time, okay? So our first part, hot, we've done that a couple times now, right? And we want hot to be true in this case as well. don't want it to be too hot, so we need to put a cap on the value of temp, because that's how we're going to measure how hot it is. So let's say that under 80 is going to be not too hot. So that means that we need to set temp to be less than 80. Okay? And what symbol would we want to be here? Since we are going to need both of these to be true in our evaluation, we're going to put an and here. But if we think back to the truth table that we did earlier, when we ran into our 32 degrees, we wanted to include that as part of our cold day, right? Do we want to include 80 as, hot but not too hot? If we did, we could simply put an equal sign right here, and that'll be just fine, as long as we get our desired effect. Okay, so now that we have our conditions, we can begin evaluating our statements using the values here in our test column. So in our first one, hot is equal to true, sunny is currently false, and temp is 45. If we look at our first evaluation, we want hot to be true, so that would check out, and we want sunny to be true. In this case, it is not. So this statement as a whole is going to be false. Next, for hot or sunny, hot needs to be equal to true, or sunny could be equal to true. Looking at our test data, hot is equal to true, sunny is false, but that's okay. Since this is an or statement, only one of them needs to be true. And hot is currently equal to true, so that works for us. Hot but not sunny. Hot is equal to true, and sunny is not equal to true. We've got hot equal to true, sunny's false, which is not true, so this one's true for us as well. And again, with that and, both of these individual statements have to be true. Hot but not too hot. So here, hot equals true, perfect. And now we've got temp at 45, that is less than 80, so that one is going to be true for us as well. Now for this next set, hot is set to false. We've got a lot of conditions that are dependent on hot being true. So you might be tempted to go through and just blanket false all these, but it's important that we go through each condition. So hot equals true and sunny equals true. Since hot's false, we can just immediately disqualify this as being false. This is our or. Hot equals true or sunny equals true. They're both false for us. So since neither one was true, we got a false statement. Hot but not sunny. Hot equals true. Sunny is not equal to true. Hot's going to disqualify us right off the bat, being false. Okay? And since that's an and, that means the whole statement is false. Hot but not too hot. For this one, hot needs to equal true. Since it's that and, that means that it's going to have to be true for the statement to return true. We automatically get disqualified because of that hot being false. So I'm going to put false right here. Okay, last but not least here, hot is equal to true, which is great for us so far here, right? Sunny is equal to true, and temp is equal to 99. We're checking this. Hot equals true and sunny equals true. Check, check. Perfect. The whole condition checks out. Hot or sunny. Hot could equal true. Sunny could equal true. We've got both. Either one would be good. We're going to put our true right there. Hot but not sunny. Hot is equaling true. Sunny should not be equal to true, but it is in this case. And since this is an and, that means since one of them is false, the whole statement's going to be false. Okay? And then hot but not too hot. So hot is equal to true, check. But temp is not less than or equal to 80. 99 is going to be greater than 80, right? So since it's an and, that disqualifies us to be false. So we had some pretty interesting but relatable conditions to work through on our truth tables. I hope you all enjoyed this activity as much as I did. I love truth tables. I actually find them very zen to work through. I bet that you're going to be much more aware of all the evaluations that you're making in your day-to-day life now, and it's great programming practice. Speaking of, if you're wondering how we would put these evaluations into code, stick around and watch the next video. Using conditional statements, we'll be building a day analyzer program that will tell the user what they could potentially expect from the weather that day and how they can best prepare. I hope to see you again soon. And remember, investing in yourself is the best thing that you can do because the return on your value is going to pay out for a lifetime. And I know that to be true. Thanks for watching, everyone. See you next time.